so far in this chapter, we've been taking derivatives of functions that are much more normal of what we've been looking at, but realize that all your trig functions actually would have derivatives as well. And so we're going to start looking at that today. We're not going to mess with the angle too much yet. We're just going to deal with basically what if it was sine of x, what if it was cosine of x, or secant, or any of those. And so as you can see here, the derivative, and again what this means is if I were to take the derivative of that with respect to x, I would get cosine of x. So the derivative of sine is cosine. And the derivative of cosine with respect to x is the opposite of sine, or negative sine of x. Okay? And those would be really good ones to remember. I'd say you don't really have to memorize the other ones, but remember that the derivative of sine is cosine, and the derivative of cosine is the opposite of sine. And so if I was to give you this first one here, it says y equals 5 sine of x, then it says calculate y prime. You can look at these many different ways, but you could look at it, let's just look at it as a product rule to start with. 5 is my first function, and sine of x is my other function. Well, then y prime would be, well, write down the first one, which is 5, times the derivative of the second one, right? So if this is u and this is v, for those who like to write it that way. So it'd be u, v prime. So v prime, it says right over there, is cosine. So cosine of x, because it's sine, I'm taking the derivative of cosine. Plus, then you write down the second one, which is sine, times the derivative of the first one, or derivative of u. Well, the derivative of a constant of 5 is just 0. So you can see here where maybe product rule was a little bit more than what we really needed, because this whole second term just cancels. And so what's really nice is any constant out in front of the trig, like this 5 here, or any number for that matter, is kind of just along for the ride. And so you can always do product rule if you want, but as you can see here, we really didn't have to. We could have just taken the derivative of sine and gotten cosine. Okay. The second one here is, you see a 2 cosine in there, which would be very similar to the one we just did, but then there's an x squared cagged along. And so then we have to decide, well, are we going to use product rule? You know, does that count as the first function, as that as the second function? No, you don't use product rule because it's plus in between, all right? It's not multiply. And so what we can do here is just take the derivatives separately. So let's take the derivative of this, y prime. Take the derivative of that, well, that's 2x. And plus the derivative of this, which we just learned in the first one, is that 2 is kind of along for the ride. And so it'd be 2 times whatever the derivative of cosine is. And so if we go back, it says here the derivative of cosine is the opposite of sine. Okay, and so negative sine of x. But keep in mind, these two terms here are still multiplied together. And so what we would probably do is write it like this. It'd be 2x basically minus 2 sine of x. So I'm multiplying those two right there, not subtracting them. Again, multiplying these two right here and not subtracting them. You could factor out a 2 if you wanted, but we don't need to here. We cannot factor out the x, though, because this x here is attached to sine. Okay, and we will have to get rid of sine first to be able to manipulate that x. Okay, so we can't factor out a 2x or anything like that. We could factor out the 2, though, okay, because this 2 is out front. Okay, and so there is your derivative. And remember, derivative is a generator that will help us find slope at any particular point. Which leads us to this question, where if we were to determine the slope of some function, so we'll say 2 cosine of x, at, well, 2 different points, it'd be really nice, instead of going that big, long way with the definition and all of that, it'd be really nice just to find that generator. And now we have a really quick way of finding that generator with our shortcuts. And so let's just go ahead and find the generator. So f prime of x equals, and we just did the derivative of that, right? It's negative, or the opposite of sine of x. Okay? So that's our derivative. And so if I wanted to know the slope at particular points, that does mean slope of a tangent line because it's at a point, and the graph of 2 cosine of x is a curve. And so it would be finding that tangent line. And so what we would do is we have an x value and a y value, but in our generator over here, all it's asking for is the x value. Later on, our generators will be asking for both x and y, but for now, right now, it's just asking for x. And so f prime of negative pi over 2 is equal to negative sine at negative pi over 2. And here's where unit circle come in handy. Well, the circle was great, the crosshairs not so much. Negative pi over 2 is right down there. Okay, and what we need to figure out, well, what's the ordered pair there? Well, that's 0, negative 1. And I'm looking for sine there, so I'm trying to do this part first. I'll worry about that negative up front when I'm done. So we're going to negative pi over 2, which means go around the circle in this direction. And so if I get down there, that value is, so far, equals negative. Again, this negative just kind of went right there. I'm trying to find out sine of negative pi over 2, which, again, sine, when you're on the unit circle, is the x value or y value? Which one? Very good, the y value. And so it's negative 1. Right? This negative 1 is sine then. And so basically it's a negative 1, right? And so it's positive 1, right? Oh, finally somebody realized my derivative was incorrect. Okay, if it's 2 cosine of x, the derivative is negative 2 sine of x. And so there should have been a negative 2 here, and so there's like a negative 2 out front, and so my answer is actually not 1, but my answer is 2. Okay, and again, what does that represent? That is the slope, so 2 is the slope of the tangent line at this particular point if I was on that curve. Of course, I'm not right now, but if I was, that's the slope at which I would be traveling. That's the instantaneous rate of change. So why don't you go ahead and try B right now on your own while I erase some of this stuff. All right. Do I have to redo the generator? No, I'm still using this generator. I'm just putting in a different point. So now it's f prime of pi over 3 equals, so here's a negative 2, just tags along, sine of x. Again, this generator is only asking for x, so that's all I will substitute in. It's not asking for y. And so if we do this work, it's negative 2, and I have to find out, well, what is sine at pi over 3? All right, so we go back into that. Oh, much better that time. Pi over 3. Well, this one here is pi over, yeah, pretty good, 6. This one's pi over, very good, 2. And then this one's pi over 3. And so we have to remember the ordered pair up there. And that ordered pair is 1/2 square root of 3 over 2. Is that correct? Yes, it is. And so here we go, negative 2. What I'm trying to replace is that part. So sine at pi over 3, we just found out, is square root of 3 over 2. And so in this case, these 2's very nicely cancel. And so I am left with negative square root of 3. Now this is a particular case where you could have tried to do something like this on a calculator, but it would have given you the decimal answer, which you would have to round, where here we have a very much exact answer. Okay? Negative square root of 3 is the slope if I were to be on that curve at that point. Again, instantaneous rate of change. So that's sine and cosine. The other trig functions also have derivatives. Those are a little bit more complicated though. So you can see there the derivative of tangent is secant squared. And remember that secant squared, that's this one right here, can be written as secant of x squared is really what, squaring trig functions means. And so same thing with cosecant squared there. You see cotangent, the derivative is negative cosecant squared. Secant is secant of x times tangent of x. And cosecant is negative cosecant of x times cotangent of x. I wouldn't say you have to memorize these, but knowing that tangent and secant kind of work together very well, and cotangent and cosecant work together very well, will probably help you in the long run. And so this one here, take the derivative of that, that's y prime. Derivative of x, be very careful, a lot of people get that one wrong. They do the trig right, and then they do this one wrong. The derivative of x is 1, and you can use power rule, right? 1x to the first. And minus tangent. So we have to do minus, well, what's the derivative of tangent? Well, we did that one right up here, right? The derivative is secant squared, and you can write it either way, whichever way you're more comfortable with. And there it is, 1 minus secant squared. Okay. And some of you may notice that as something that we dealt with last year in advanced math with one of the Pythagorean triples. I'm not going to worry about that just yet, but I do believe that we could simplify this particular one, but we'll leave it like that for now. Well, so far, with all the trig that we've had, it's been pretty straightforward. But the only one that we had to try anything tricky with was this first one where I said, well, let's try product rule and see what happens. Well, I didn't need to use product rule there, but please realize trig can show up in product rule, can show up in quotient, and it can show up, in many of them. And so this one right here actually is a product rule because I do have a function x, and then I have a function secant of x. Okay, so if we were to term that derivative, we'll say y equals this, I suppose. And so then we'll do y prime. And so write down the first one. And this is product rule, which we know is commutative, and so is the product rule because there's addition in it, and so we're fine. So we'll write down the first one times the derivative of the second one. So you look at your sheet there, and the derivative for secant is secant of whatever the angle is, x, and tangent of the angle, which is x. Okay. So is that the derivative? Well, not quite. Pretty close, though. So plus. So that's basically, right, that would be u times v prime. Now we're going to do v times u prime. So here's secant of x. So we got to write down the second one times the derivative of the first, and the derivative of x. It's just 1. And this isn't over anything squared or anything like that, or over 2a or anything like that. This is just what we've got. And so in this case, there is probably one thing I would do here, because this is all multiplied together, and this is all multiplied together. So I would probably, if I was looking at this one, I would factor out the secant of x. Okay, because that you can factor out. I can't factor out just the x part of the secant of x, but I can factor out secant of x in both of them, and I'd be left with what? X tangent of x, and be careful here, plus 1. Okay, and that's what I would do there. You don't really have to, but I just saw that it's a nice easy factor, and so we could do that. And so again, on your assignment, you may be asked to do quotient or product and have it just within it, but you can just recall what their derivatives are from your notes.